Let us discuss about light-emitting diode or LED. Light-emitting diode, which we also call LED, is nothing but like p-n junction diode. Nowadays, LEDs are most widely used in semiconductor diodes. These diodes emit light when it is forward biased. Normally, these diodes are formed by a p-n junction. This is a semiconductor p-n junction. This diode has two terminals, anode and cathode. This is anode or positive terminal. This is cathode or negative terminal. The p-n junction is surrounded by a transparent hard plastic epoxy resin hemispherical shaped shell to protect the diode from external shock. This is a transparent cover of the diode. Although we have already said that LED is the same as ordinary p-n junction diode, but it is also true that ordinary p-n junction diode does not emit light when it is forward biased. Now we will try to explain what is the speciality of LED, so that it can emit light which the other cannot. When any diode is forward biased, current flows through the diodes. In forward biased condition, positive terminal of battery is connected to p-type end, and negative terminal of battery is connected to n-type end of the diode. Current is caused in the diode due to flow of holes and free electrons both. Here, holes are injected by positive terminals and migrated towards negative side, and electrons are injected by negative terminal and migrated towards the positive side. During this process of flow of holes and free electrons, there will be recombination amongst them. That means free electrons will recombine with empty holes. During this recombination, electrons in the conduction band, that is, free electrons will jump to the hole in valence band. During this jump of electron from conduction band to valence band, electron emit energy in form of photon. This energy is equal to the forbidden energy gap between conduction band and valence band. Here it is to be noted that condition band is at higher energy level than valence band. We know that the energy of a photon is nothing but the product of frequency of electromagnetic radiation and Planck constant. Now consider the energy gap is Eg. Hence, Eg equals Hf, where H is Planck constant and F is the frequency of electromagnetic radiation. Now it can be said that Eg is proportional to F. This is what we do in light-emitting diode. We have already said that photon will release in all electron-hole recombination, but light only emit in LED. Let us explain why. Velocity of electromagnetic radiation is fixed, and it is equal to the speed of light, that is c. The frequency of radiation f is related to velocity of light, as f equals c by lambda, where lambda is wavelength of the electromagnetic radiation. Hence, from equation Eg equals Hf, we can write Eg equals Hc by lambda. So we have seen that wavelength of electromagnetic radiation is inversely proportional to the forbidden energy gap. In normal silicon, germanium semiconductor, this entire radiation of electromagnetic wave during recombination is in the form of inferred radiation. The wavelengths of the inferred are out of our visible range, so we cannot see it. Inferred electromagnetic radiation is nothing but heat. This is because silicon and germanium semiconductor are not direct gap semiconductors. Rather, these are indirect gap semiconductors. In indirect gap semiconductor, the maximum energy level of valence band and minimum energy level of conduction band do not occur at the same momentum of electrons. Hence, during recombination of electrons and holes, that is migration of electrons from conduction band to valence band, the momentum of electrons would be changed. The photons originated from these electrons will be mostly utilized for the electron momentum. In direct gap semiconductor, the maximum of valence band and minimum of conduction band occur at the same electron momentum. Hence, there will be no change of momentum of electrons during migration from conduction band to valence band. So the photons originated due to that migration have not to provide momentum to electrons. Unlike normal diodes, which are made from either germanium or silicon, the indirect gap semiconductor materials, light-emitting diodes, are made from direct gap semiconductor, compounded such as gallium arsenide, gallium phosphide, gallium arsenide phosphide, silicon carbide, gallium indium nitride. Also, they may be mixed together at different ratios to produce more distinct wavelength of colors. This is how an LED or light-emitting diode works. Hope you got the idea. Thank you.